Hello guys, welcome to this video. So in this video, we'll be learning how to size solar charge controller correctly. Okay, when it comes to system sizings, after sizing your inverter, batteries, solar panels, okay, so if you decide to use a external charge controller, you need to also know how to size the right capacity of solar charge controller that will have solar system design. And that's what I'm going to teach you in this video. How do you size solar charge controller correctly? Okay, so let's get started. So one thing you need to understand is that the goal of charge controller, the goal of sizing your charge controller is to make sure that it handles the right current and voltage from your PV areas. Okay, so if you have decided, okay, if you have actually sized your solar panel, you know the amount or capacity of solar panel that can charge your system efficiently. Okay, so if you have obtained that information, the next thing to do, if you are not using an inbuilt hybrid inverter that has an inbuilt charge controller, you need to also size the charge controller that will manage the charging of your system, that will manage that PV areas. So you're not going to go there and just use any charge controller there without knowing the specification is going to handle your PV areas need. So you need to size them correctly. And what information do you need to size them correctly? The information you have about your solar panel. Okay, now we have, in previous video we did how you can size your solar panel based on your solar need, daily energy need. You size your solar panel, know the capacity of solar panel you need for the system. Once you have gotten this information, you will now use this information to size the charge controller that will handle the charging current and voltage of that system. Okay. So with this said, we have highlighted earlier when I talked about, if you check the previous video, I will highlight it here. In previous video, we talked about where I explained about charge controller. We didn't go into details of sizing it for a system use. We just functions of charge controller, what it does, and all that. In that video, we highlighted what charge controller does. Okay, 4 major things that charge controller does is that it regulates voltage regulations in system charging. Okay, it also regulates current regulation. Make sure that current flows properly and doesn't damage batteries and all that. It also charges in stage, helps your battery to charge in different state, to charge very well, healthy charging. Charge controller does that. And also temperature, to minimize temperature and all that, so that the system doesn't get overheated or experience over temperature that might shut it down and all that. So these are the basic things charge controller does on the system, which should be noted. So after discussing the functions and what charge controller does in a solar system, we also highlighted different types of charge controller. We mentioned about MPPT, which means maximum power point tracking. We also talked about PWM, which means pulse width modulations. So these are the two different types of charge controller, external charge controller you find out there. Okay, so they work differently, they operate differently, and you need to know this. We need to note it here in sizing so that you know the exact type you are going to go for. You need to be specific, know the functions of each of these charge controller in any given situations. You also know the one that is going to be needful, the one that is going to serve the purpose of your system, the one that is going to serve your system correctly. So when it comes to PWM, there is one feature we know about it. We know that this type of charge controller works best when the solar panel voltage reasonably match, okay, the battery voltage. So the PWM doesn't have the power to convert excess voltage and all that. It just works with what you give it to it. So when sizing this, you need to make sure you are working with the right voltage of your battery. You don't need to create connections that exceed the battery voltage. Your connection has to be within the charging voltage of your battery system. Okay, then one thing about MPPT charge controller is that it can convert excess voltage to current. It has this inbuilt ability to convert excess voltage to current, and that's what makes it more efficient than PWM and also more expensive in the marketplace. But these major features are things you need to understand about the two types of charge controller, because it's going to determine what you are going to go for, okay, in any given situations. Okay, actually MPPT is the best, both on efficiency and all that, is the best charge controller out there to work with. But for educational purpose, we need to highlight it, because you might also be dealing with a small system. You don't need to spend extravagant on MPPT. You might decide to go with PWM. It's going to work, but you're not going to expect these extra functions of converting excess voltage to current to charge batteries and all that. You're not going to expect it from PWM charge controllers. Okay. So with this said, let's look at the three things. Okay, when sizing charge controller, three major things you need to consider, three major things you need to size correctly when sizing your charge controller. One of them is the current. Okay, every charge controller has a specifications, the amount of current it can handle. So you need to size this in respect of the system you're going to use that charge controller on. You need to make sure it matches very well, and I'm going to walk you through on how you can do all these things. Another thing you need to consider is the voltage. Okay, every charge controller also has maximum voltage, which is the highest amount of voltage it can handle at any given time. So when sizing a charge controller, you also need to put this into considerations. Okay, another thing again you need to consider is your system voltage. Okay, you're going to be using the charge controller on a system, and that system has already defined voltage. Remember, when sizing a system, the first time you define the system voltage is when you are sizing your inverter. Any voltage you decide on the inverter is what every other thing is going to follow through. Your battery, your solar panels, your charge controllers, okay, they are going to maintain that voltage. So you also need to size your solar charge controller based on your system voltage. Okay, you don't have to mismatch the voltage. So if we have these three things cleared about sizing our solar charge controller correctly, let's briefly look at how we get to obtain this current, voltage, and all that in solar panels. So we get to obtain this. Okay, what changes our panel voltage, current, and all that? Apart from the specification you read on panels, what can change those specifications in connections is panel connections. Is how you connect your panel that will determine how the voltage will turn up, how the amperage will turn up. Okay, so you need to understand panel connection. We are not going to go deep into this. I'm going to create another video, probably on a rooftop or any a special video that I'm going to explain to you about panel. For now, let's briefly look at how voltage and current on your panel gets to multiply or changes in terms of your solar panel connections. Okay, so what you need to understand about panel connection, take note of this, is that we have series and parallel connections. And when you connect your panel in plus and minus, you bring plus from this terminal, you bring minus from it, you turn it, you join it together. That is called series. So you need to multiple times, plus and minus, plus and minus, plus and minus, plus and minus. You can do that and have like 6 series, 3 series, 2 series, 5 series. These are called series connections. And when you do that, what happens? The voltage of the panel will increase and the amperage will remain constant. Okay, if you connect panel that has 45 volts, 11 amps, you connect 5 of them, series. What you're going to be having now is 45 times 5, while the amps will remain the same. That is series connections. With this, you can connect your panel anywhere. Okay, I'll show you a picture diagram that explains it better. But also parallel connection is when you connect plus to plus. Okay, this you're not going to, in terms of parallel connections, your voltage will remain constant. Is your ampere that is going to increase. For example, I want to connect them in parallel. Okay, so what happens here? My plus and minus for one panel, plus minus will go to plus minus of the PV string, the wire that is going to charge controller or battery. Plus and minus will go to plus and minus of this panel. This panel also, plus and minus will go to plus and minus. This is how parallel connections are done. And when you do that, the voltage will remain, even though it's 5 panel, the voltage will still remain 45. But while the ampere that is 11 will now be times 5, which will give you 55. So these are basic panel connections. So if you understand this, you can now move further to, okay, deciding on how you're going to size the capacity of charge controller you are going to use based on the connection you want to achieve. Okay, now let me show you what I've just explained about this connection aspect. Now let's say, for example, this is a solar panel in series connections. As you can see, this panel is rated 12 volts 8 amps. There are 3 pieces. If you connect this panel in series, this is what it does. Plus and minus connect here, plus and minus connect here. You have connected the 3 panel. Then the minus here is going to go to the string of the PV, the one going to the charge controller or inverter. Why this one will go to, okay, also the plus of charge control, the wire going to charge controller or inverter. So if you total this is what we are getting in a series connection. 3 panel, 12 volts, 8 amps. We are getting 36 volts, 8 amps. Okay, so these series connections, you see it here, the current will remain the same while you times the voltage. If you want to get the total wattage, you have here, you see 36 volts times 8. So if this is 45 volts now, if you do it now, you also get the total wattage. So this is the total capacity of these solar areas, 288 volts. Now here is an example for parallel connections. You see it here now. 12 volt amps, 12 volt, 8 amps, 12 volt amps. Connect it in parallel. Each of these panels are going straight to the string that is going to charge controller or inverter. Plus and minus go to plus and minus on the string wires. Okay, if you do that, the voltage will remain constant while the amps will multiply. Here is it now. Voltage is 12 volts. Amps is 8 times 3, 24 volts. If you still do the calculation, you still be arriving at the same capacity of PV areas. So these simple connections, you can work with this. Even though you are doing 10 panel, 20 panel, 100 panel and all that, this is same formula. Okay, you just know your limitations with your charge controller. All these things are going to determine, okay, how many, with this connection now, how many panels is my charge controller going to handle? That is going to be the same. But just understand these basic connections. Okay, so with this said, let's move on to determining your charge controller size. So how do you size your charge controller? It's simple. Okay, requires solar power divided by system voltage. That is how you charge your charge controller. It's simple. So how do you come about this? We have sized our solar panel based on our daily energy use. We determine that, okay, so amount of power, if we can generate so amount of power in 1 hour for 4 hours based on our peak sun hours, we'll be able to charge this step, or we'll be able to provide enough energy that will sustain or that will take care of our energy need, our daily energy need. If we have decided that already when we did our solar panel sizing. Right? What you're going to do now to size your solar charge controller is that your required solar power, required solar energy you need to generate under for 1 hour every day for 4 hours. I'm going to substitute it in these equations to be able to size your solar charge controller properly. And here is the simple. Our required solar power based on our calculations, based on our energy needs, battery charging capacity and all that. These are our required solar power. We need to generate this 4063 watt hour every hour. We need to generate it on every hour starting from our solar panel, and we need a charge controller that can handle this capacity. That is our goal here. In every situation, it's the same thing. After you have sized your system, daily energy load, you decide on the inverter capacity, you decide on the battery that can power the energy throughout the day, you decide on the amount of solar capacity that can charge the battery and power the load throughout the day, you decide on the wattage of the panels you want to work with. The next thing is to come with your required solar power to determine your charge controller. So our solar power here, we divide this. Our system voltage here is 48. If you are working on a 24 volt system, it's going to be divided by 24. If you are working on 12 volt system, amount. Okay, so with this now, let's substitute it. Okay, so if we do 4063 watts hour divided by 48, which is our system volt, we are getting 84 amps. So what is this saying? That we need 84 amps of charge controller to handle this system. And in solar charging, okay, you need to add some margins. Okay, margins for surge and all that. Okay, that can occur during performance, during operational, doing operations. So you need to include margins, and the margins regularly used in this, in adding, okay, safety margin for charge controller is 1.5, which is approximately 25%. So if you do this 84 amps, which we have gotten, times 1.25, which is 25% of our total amps, you are getting In total, if you add it up to our 84, you are getting 105 amps. So in nutshell, you need about 105 amps charge controller to be able to handle this capacity of solar areas. Okay, so that is basically it. With this, you have sized, you know that if you have a 120 amps charge controller, okay, that is rated for 8 volts, okay, you'll be able to handle this capacity. Now, another thing you need to check is the maximum PV of your charge controller. That one, how you're going to connect your solar panel. Your maximum PV is going to decide how you're going to connect your solar panel. Okay, so if you look at these calculations now, you see that we require about 120 amps. Okay, more like a safety margin, but 105 amps charge controller is going to do this work because we have already added a safety margin. Even 10 charge controller is going to do this work, but safety's sake, you might not actually see a charge controller rated at 105 or 110. But if you see a 120 charge controller is best for this job. Okay, so let's look at some examples. Let's take some examples for you to understand about the current aspect, the voltage aspect, and all that. Let's take, for example, examples on current. Let's say you have a panel specification of 11 amps. Okay, and if you connect the and you need to connect the, you have 6 panels, you need to connect it in parallels. Now let's look at our outcome. So we'll have 11 amps times 6, 66 amps. If you add our 25% safety margin, you'll be getting 82.5 amps. So in this case, if you have a solar panel that is rated 11 amps and you're going to be using it to connect a solar panel, you're going to be using it to connect a solar panels up to 6 pieces. Okay, so this is the safety margin you need to go for. You need to make sure that you have at least, okay, a charge controller that is rated 82.5 amps to be able to handle this situation very well. Okay, or 100 amps approximately. A 2.5 amp solar charge controller can charge this system correctly, but you can run it up to 100 amps charge controller. Okay, you might probably not see a charge controller rated at this amount. Okay, but 80 to 100 amps charge controller is suitable for this system. So let's take another example for example of voltage so that you understand. Now let's say, for example, your charge control has a maximum PV input voltage. Is an MPPT, is rated 160 volts. That is the amount of voltage it can take from solar panel. It cannot exceed this. If you exceed this, it gives error. Okay, now if you have panels, your panel voltage, maximum voltage is rated at 45. Okay, so and the amps is rated at 11 amps, and let's say you need to connect 6 panels. Okay, so safe connections. How do you connect this kind of panel? What you can do on this panel is to maintaining the the voltage range. Maintaining the voltage range. The charge controller that is rated 160 volts, the ampere should be higher, at least higher than 60 amp. But in this case, you are looking at the voltage. How do you maintain a safety connection within the voltage of your charge controller? So if you have a rated charge controller in this capacity, and you have a solar panel rated 45 volts, the amps is rated 80 volts, and you are meant to connect 6 panels. Your safety connections there is going to be three series and 2 parallel. What does it mean? You connect 3 panel plus minus. You connect the other 3 panel plus and minus. You have gotten 2 series. Then these 3 panel, the plus and minus will go to plus and minus on the PV string. Then this panel also, the plus and minus will go to plus and minus on the PV string. That is 2 parallel. So this is the safe connections you can do on this. Even though it's 6 panel, you can also do the same thing. You just have to, on that case, then you only have to worry about your parallel, so that the parallel accumulation, okay, will not exceed the charge controller ampere. That is just it. But 3 series, okay, as it is now, we'll be having what? We'll be having 5 times 3 series, because when you do series, voltage multiply. When you do parallel, voltage remain constant. Now we did series of 3, the voltage is going to multiply times 3. So this is your voltage, and it's okay for this charge controller that is rated 160. Okay, so and our amp is going to be what? 11 times 2, 22 amps. Okay, basically with this kind of connections, based on voltage, okay, based on voltage, you are safe and clear. Okay, so even though you have 12 panels here, if I do 3 series times 4, we have 12 panels, and our parallel is going to be 4. So that means our voltage is still going to remain 160, but our amps now is now going to be what? 44. Okay, so that is basically it about all these calculations. Now let me highlight. Now we are talking about all these things based on external charge controllers and all that. What if in the situation whereby you are working with high voltage hybrid inverters that are high voltage? Okay, high voltage inverters are inverters that have inbuilt charge controllers, but their PV voltage, the maximum PV voltage is very high, from 3 something to 400 or 500 voltage. They can handle that kind of voltage. So their connections and configuration are always different. So in that regards, if you are working with hybrid high voltage inverters, let's say for the inbuilt MPPT rated, the voltage is 450 or 500, let's say 450. Okay, let's also say the minimum voltage in hybrid inverters are like, if your panel connection voltage does not get to this amount of volt, that system solar is not going to peak. It's not going to peak charging. So you must meet up with this minimum voltage. This is the minimum voltage that can start up the inverter system. Okay, then also maybe the high voltage inverters always have high amps because they work with voltage. They don't have high amps. So you might have an high voltage inverter that has 45 volts, 450 volts, while the amps is like 20 or 15. Highest you see 27 or 30. So there must be put into considerations. Okay, so let's say you have this type of inverter you want to work with, and you want to know how you're going to connect your panels safely. Okay, so this is what you do. The maximum voltage is 45, the amps is 11, and you need to connect 6 panels. How do you go about this kind of connections? What you're going to do is, safe connections here is to connect 6 series in one parallel. Okay, so your goal here is to make sure that whatever you connect, don't let this voltage, your connections in series should never exceed this 45 volts. That is your benchmark. So whatever you're going to do, okay, 45 times 1 times 2 times, let's say you connect 45 times 8 here, okay, or times 9. So don't do any connection of this maximum voltage to in whatever numbers of series you connect. Don't let it exceed 450. Don't let it exceed the maximum voltage of that hybrid inverter. Okay, it can get something bad there, or it's gonna give you an error message. That is just the big deal of working with inbuilt charge controller in solar system. Okay, in this regards, if you do 45 volts times 6 in series, one series you connect plus and minus plus and minus plus and minus plus and minus into 6 places. That is 6 series. Then one parallel, the end of that 6 series plus and minus, there are 2 end, positive and minus, is going to go to the string wire that goes to the inverter, or inverter actually. Okay, so with this now, you are okay. If you do 45 times 6 series, you are getting 270. You are okay with this inbuilt maximum PV volt of this inverter. And if you check, you also cause the minimum voltage for this inverter to start working. As you can see now, we have 270 volts. It simply means that this inverter can take at least, before it exceeds, can take up to 2 more panels or 3 panels before it exceeds this volt, which is the maximum PV inbuilt of this hybrid inverter. Okay. So basically, this is how you size charge control system, whether inbuilt or external charge controller. Also know that hybrid inverters not only come with high voltage MPPT inside. Some of them come with PWM charge controller inside, which has minimum voltage. Okay, they has less maximum voltage within 100 and all that. They don't exceed that. In that regard, also you need to also obey that. So the rules in connecting your panels with charge controller or inbuilt charge controller, work with the maximum voltage and with the maximum amps of that charge controller, whether internal or external. You need to work with it. Don't exceed it. Okay. For example, this charge controller now, if I should do 6 series, okay, 6 series, I bring another 6 series, I connect 6 series into 4. okay, which is we'll be having about 24 pieces of panel. Then I will now have about 4 parallels. Okay, so if you do that 4 parallels, if we times the 4 parallels times our 11 amps, you see that we'll be getting about 44 amps. Okay, on that regards, you know that we have exceeded the charge controller inbuilt amps rating. It's going to give the inverter error. Okay, so these are the rules you should obey. But if I do 6 series, let's say I have 6 panels and I do this 6 series times 2, that means I will be having 12 panels, 6 series times 2 parallel. So if I do that connection, it's going to work on this system. First, our voltage is going to still remain 270 volts, while our amps is going to increase to 22 amps, which is still underrated. It's under the rating of this inbuilt charge controller, which means we are safe. Okay, so if you follow these rules, you're able to size your charge and also the connections will be perfect. You'll be able to do the connection correctly based on the numbers of panels you have decided to use to achieve your total capacity you need. Okay, so basically that is it about sizing charge controller. I hope I get to explain these things in details. If you have questions in anywhere or anything we have explained here, okay, endeavor to ask on the comment section. Okay, and also remember to follow us, because we are going to be sharing more in-depth training and information about solar system for electricity. Okay, stay in touch, like, share this thing more useful, and I'll see you in the next one. Bye for now.